Hello everybody. Today we are going to discuss magnetic field at a point on the axis of a current carrying circular conducting loop. Magnetic field at a point on the axis of a current carrying circular conducting loop. Okay. Now before we are going to discuss or going to derive the expression for the magnetic field, let us draw the basic diagram of this circular current carrying loop. Suppose this is the circular current carrying loop and its radius is a. Okay, now let us draw a perpendicular straight line that is through the origin of the loop. This straight line is perpendicular to the plane of the loop, and we have to calculate the magnetic field at any point on this straight line. Okay, that is it is actually the axis of this current carrying loop. Suppose we want to calculate the magnetic field at this point. Say this is a point P. Okay, to derive the magnetic field at this point P, let us consider a small element on the loop of small length dl. Okay, now due to this small element, the magnetic field at this point will be, suppose, dB. Okay, now what will be the direction of dB? So first of all, draw a straight line joining this point and this point P. Okay, the angle here which formed by this straight line and this axis, say phi. Now we have to understand the angle between this dl and this straight line of suppose length r is actually 90 degree. How? Look at these two pens. Suppose this pen is dl length of this and this pen is this straight line. Okay, and in such a manner the angle between these two pens are always 90 degree. If I rotate this black pen in any direction with this green pen, then always the angle between these two pens are 90 degree. So the angle between dl and r always 90 degree. Okay, so let us write down this angle between dl and r is always 90 degree. Okay, actually this is the angle theta according to Biot-Savart law. Now what will be the direction of dB? Let us first elongate this straight line r along this in the same direction, and the direction of dB will be always perpendicular this straight line, that is along this direction. This is the direction of dB. Now there will be two components of dB. One is normal component and the other is tangential component. If this angle is phi, then this will be also phi. Okay, therefore from the basic idea of geometry we can write this angle from our primary consideration. This angle is 90 degree. Okay, and this is also 90 degree. Okay, and here this is phi, so this angle will be 90 degree minus phi. Okay, so what will be this angle? This angle will be 90 degree minus 90 degree minus phi, so 90 degree minus 90 degree minus phi is equal to phi, so this angle is phi. Therefore the component along this direction is dB cos phi, and along this direction is dB sin phi. Okay, now let us draw this diagram again. This is again DL, this is A, this is R, this is dB, this is dB sin phi, this angle is phi, and this is dB cos phi. Similarly, if I consider another component DL here, just opposite to this element DL, then there will be another part which is also this is dB, this is dB cos phi, and here dB sin phi. Okay, this angle is phi, also this angle is phi. From this figure, this dB cos phi and this dB cos phi will cancel each other. Okay, and these components of dB sin phi will sum up. Therefore, for the entire circle, we can write in the form of integration that total magnetic field B is equal to closed integral of dB sin phi Now closed integral of dB. What is the value of dB? From Biot-Savart law we can write mu 0 by 4 pi. If the current through this conductor is I, then I dl cross R. Cross R. R means, for this case, R is perpendicular to this dl, so we can write this is sine 90 degree by R square, and for this sine phi we can write sine phi. Okay, is equal to closed integral of mu 0 I by 4 pi R square sine 90 degree is equal to 1, here dl, and for this sine phi the value of sine phi is this by this, I mean a by r, is equal to mu 0 I by 4 pi r cube, here a closed integral of dl is equal to mu 0 I a by 4 pi r cube, dl means closed integral of dl means 2 pi a. Therefore B is equal to, this pi will cancel out, this 2 by this 2 we can write here 2, therefore we can get mu 0 I a into a square by 2 r cube. Okay, what is the value of r cube? What is the value of r in terms of the distance from the origin to this point P? If I consider the distance between these 2 points is x, then we can write r is equal to root over of a square plus x square. Therefore B will be mu 0 I a square by 2 into a square plus x square whole to the power 3 by 2. Okay, this is the expression for the magnetic field due to a circular current carrying conductor on the on any point on the axis of this current carrying conductor P.